Good afternoon, everyone. Thank you so much for coming today. My name is Liu. I'm a second-year PhD student here from DASP. And about several months ago, when Andrews told me this seminar today, he suggested me that to brief a case study about using urban imagery data set for urban planning project. So before I came here, I had a startup team focusing on urban big data to provide planning institutes with some consulting service. So today I will introduce you a brief case. As you can see, we can get a lot of information from street view images, a lot of details and about our daily life and public life and so on, like the greenery and the sky view, buildings and pavements and all the dynamics of traffic and pedestrians. But my point here today is that although we can have on the right side, we can have a lot of data source, like using cameras and videos to collect the information from our public space, and also using a lot of tools called, which is maybe sounds weird to you, like segmentation, object detection, and also some heat maps for customized detection of some specific objects like informal vendors. But those kind of techniques are only appropriate for understanding the physical environment from my experience, from my past experience. It is not very good for understanding the pedestrian behaviors, although as an urban designer, we are focusing on the interaction in between. But it is unfortunately, my talk will only focus on the lower ground, the lower part of it. But it is also another reason why I'm here, because I'm also interested in understanding the upper front of it. My case today is a little bit special. It is not a street view image, it is a waterway view. Though the name is called urban ground image, urban ground Florida, but I think they are still on the ground, so I'm not cheating. It is a part of a Hangzhou comprehensive planning. Our mission here is very simple. It's trying to identify how consistent it is between today's view in comparison to a view 800 years ago. Why 800 years ago? Because there's a very famous painting in China called Dwelling in the Fuchun Mountain. It is very, very famous, which also makes this river very famous. Because it's a representation of the ultimate spiritual purchase of traditional Chinese scholar officials. And also there's another hidden reason why this project is so important, because Mr. Xi Jinping, he was the former leader of Zhejiang province, and he delivered, this project happened about 6 or 5 years ago. He delivered a statement called Green Mountains and Green Waters is a mountain of silver and gold, which is pretty impressive. I was surprised by his views about urban planning, and also the reason why it is so important is because of this. The landscape has been already destroyed by a lot of overloaded residential buildings or constructions along the river. So how can we identify those situations in a quantitative way? Our customer, actually, they are actually my pre-colleague. They're from the planners from China Academy of Urban Plan and Design Institute. And they just took a video shots for the entire river. But unfortunately, the river is very long. It's over 200 kilometers. And it took them 7 hours from this point to that point. And when they go back home, they do not want to see any videos anymore from them. So they just handed this project to me. And well, we need to make a live. So we just try to analyze all those videos and to complete our mission, as I said before. So, and even you can see there's one video which is broken, but we cannot do that. It's a real case. The first thing we need to do is geolocating all the things manually. Based on the key views along the riverside, we try to identify some key views, and thank goodness the boat has a very steady speed, and the route is very fixed along the river, so we can still find the place where those pictures belong to, the key frames. And as you can see, the river name is a little bit complex because it has 3 names in 3 different segments, but it's an entire complete river called Qiantang River, Fuchun River, and Xingyang River, but it doesn't matter. As you can see, due to the broken of the video, there's some missing part here, but it doesn't matter. We just try to analyze what we have. So the first thing is trying to use the segmentation techniques. But Miriam was supposed to be here, so I did not try to explain more about it. But you can see what's the reason. So first, we need at that time we do not have very customized model for identify all the elements from the image in terms of urban design world. So we just borrow a model from computer vision world, which can identify a lot of things, which is not necessarily relevant to our topic. So we only pick up several items which are necessarily relevant to our research. And we try to eliminate all the other unrelevant items here. Okay, sorry. And reclassify them into 7 categories here: sky, water, building, ground, mountain, boat, wall. Maybe this is not wall. I think it's dam about resistant of the flood in some special period of time. So done, everything's done. We just translate all the images from the right side to the left side. Why? Because we can use the pixel count for quantitative analysis. But this is just the beginning of our project. So the first thing we did for those understanding the situation is you can look at the pictures in the bottom here. We just try to create a percentage stack chart in reflecting the proportional of those pixels for each image along the riverside, so that you can imagine this river here as a line. We just pick up all the both endpoint of the line and stretch into a very straight line, and to see from this place to that place to see how much the pixel ratio proportion changed along the river. For example, here in this area, it looks pretty yellow. So that means there are a lot of buildings can be seen from this period of time. From this side here, I don't know if, oh, I cannot see from this side. And for example, here, you can see a lot of dark green area, which means mountain, which reflecting this area. So this is a map from the south side to the north side. And that area, you can see a lot of trees here. So it means we cannot see much building over there. And the next step is we try to create a ratio called building height over plant height, which is manually created by ourselves, because the reason is the ratio, pixel ratio, is only a reflection of the area. But I think, we think the height of the building is more dangerous to the landscape protection. So the higher is more unacceptable for our purpose. So we need to identify something like that. And the reason why we need to use the ratio is because of the focal length was changed during the boat driving. So we have to find a way to normalize the data set. So here's come our output here. We first identify those areas which has a building ratio over 5%, like this area. And then we calculate the B over P ratio for different areas. So we can, here just a very rough illustration for our output. This is the output from the north bank of Chenhang River, which looks okay, but there's some overloaded building here. But for the south part, it's very problematic. I think there are a lot of buildings over there and we cannot see anything else. And also in the middle part of the Fuchun River, we can see there's still some outliers in between those areas. And the south part, and even in the upper stream, which is upper stream called Xing'an River, which is supposed to be a very rural area in China, but still we can find some buildings under construction over there even. And it is not a very good situation that we expected to see. So this is the first step we have done before for the identification, because we have a general map overview of the situation, how we are dealing with. But this is not enough. We further created another index called identity index. It's a little bit complex. So first we need to group all those photos for each segments. For example, here we can see these are thousands of photos which are taken in that area for the south bank of Fuchun River. And these are thousands of photos in another place. And then we use a machine learning techniques called computer matrix to compute the similarity among them, among the 6 groups. And we just created a manually called identity index, which is not the real name of it. The real name is called the accuracy rate of the computer matrix, but you do not need to remember it. The interpretation of the name is pretty simple. The value here represents the uniqueness, the degree of uniqueness of that group. So it means if you have a higher value of that area, that means a picture from that area is looks very different from in compared to other places. This is a very powerful method because once you have a very large data set, you can compare from this place to another place or even another river or another any place in the world. So it's very useful tool. But the higher value does not indicate, it is not an indication of a good situation. In fact, in our project here, the high value of the south bank of Qiantang River is very unacceptable in terms of the overloaded construction. And another thing we have done so far is using the D features to do the view classification. It's another way of explaining the world. So I won't go too many details about it, but just remember that we can just use the D features to let the machine to automatically classify all the views into different types so that we can see, now we have this example, we have 7 types of the views, and we can replot them back to the river to see how distributed are these types in the river, along the river, which is a little bit different from the previous example, because in previous example, we have identified 7 groups by ourselves, and then we calculate the similarity. But in this case, we just eliminate all the location information about those pictures and let the computer decide which one looks similar to another place. So these are 3 different ways to do that. And our final output is a little bit fancy at that time, but not fancy today. We just delivered a web portal and handed over to our customers, and then delivered transfer to the municipal government in Hangzhou. And they can use this tool to see all the things I described before. I think one important contribution we did in this project is finally they try to constrain some development along the riverside, along the waterfront area, especially for the south bank of the Qiantang River. But we are not, but though this is in China, but we are not going to identify some particular outlier cases and tear those buildings down. We can never do that, something like that. But we just try to control the overloaded building to develop in the future. And here comes up with the conclusions. The first one is, I think those urban imagery data set can provide us a very detailed environmental situation. It's very good for overview, and especially when the data set is very large. For designers and planners, it is very hard for us to manually digest everything, what's going on in that map. And second one is we can customize a lot of index as our based on our expertise and based on our experience, and we can try a lot of different combination of the ratio. I just introduced you about the building height over the plant height, but maybe we can try to the building height over the mountain height or whatever we want, and we can try a different combination of those data set and to see the plot. And the third one is once you do not have any intuition about how to use the data set, you can even hand over all the data set to computer and to machine learning to cluster all the things into different types automatically. And that will give you a very basic sense of how the data looks like, which I did not introduce too much today, but from my experience, it's very useful, especially when you have no idea about what you're going to do with those data set. But the fourth one is also very clearly that it is not very ideal for dynamic objects, For example, you can have a picture of a people in that area, but you do not know when the people shows up at that time. But what if the people just disappear in another time? Then such a kind of detection is kind of like less convincing. So today we are talking about all the things are more permanently existing there, like the building, the tree, and mountains. After this project, I have two takeaways. One is we need more geolocated visual data set because we do not want to go back to the dirty works we did in this project, like the geolocating all the videos and the cameras together back to the along the riverside, which is very, very tough work for us to do. So we provide a WeChat mini app. We developed it by ourselves and provided to other urban design designers and planning students or even planners for them to collect the photos for their field trips, so that they can just focusing on the content, focusing on the map. Another takeaway I have is we need some collaboration with human behavior data. This is another case we did in Chongqing, which we duplicate the model, duplicate the methods from Zhejiang here to here. But unfortunately, we did not find a lot of interesting findings for that because this area is a highly dense area. We don't need to care about whether the landscape is preserved or not because it's not preserved at all. So when we want to go deeper into how the people living there along the riverside, we need some other data set. For example, like the LBS data set and cell phone data set to see where people come from and how they are interacting with the physical environment. So that's another hint that we need to use this data to collaborate with other more dynamic data sets. Okay. That's for today's introduction. Thanks.
Yeah,
hi.
It's partially a question for you, kind of a question for Marion, but I hope that either you or you have the answer to it. So I've been trying to train an AI model in Amsterdam, looking at windows, ground floor windows in Amsterdam.
Mm-hmm.
Holy grail is having that object recognition.
Mm-hmm.
Look at windows.
Mm-hmm.
I've really been struggling. How's it been going for you? Like, is there any progress in your regular sort of urban image recognition models? Because I mean, so much of the ground floor experience has to do with transparency, and currently for me and an assistant, we're going through hundreds of images of the transparency of the front page. Any progress?
They're basically in maybe 3 years ago, the traditional way is trying to collect a lot of labeling data set. We need to hire a lot of people to label using the bounding box to label all the, maybe in Amsterdam case, you need to bounding box for those windows. But it depends on many things. For example, the data set, the quality of the data set, and how the diversity of the window looks like.
So Google Street View data.
Yeah, I know, but it depends on what kind of windows are you trying to identify. If they are very diverse, you need more labeling data set. But today we can use something more fancy called like the 1 pixel shot, a 0 shot for that first. Then it can narrow down our scope of the data set. We can use smaller amount of data set to train the model. But that's a very long talk, but we can try. I mean, we can try some fancy techniques to narrow down the amount of the data set we need.
Thank you. It's a good question, but I hope they're related. So I'm curious, firstly for the automatic clustering, like presumably the machine is making an algorithmic division.
Yeah.
Cluster.
Yeah.
Do you know what goes into it? Like how did it get it
based
on previous data?
Do I need to explain? So basically, we use a deep learning model. It's called a convolutional neural network. So we throw a map into a network. Then the output is kind of like the high dimensional vector. So basically, what's the digit numbers behind this picture in machine? We have RGB data set. If you know using Photoshop, you can see the RGB data set. It's a human readable data set. We can see the view of it, but it is not machine understandable content. But after the convolutional neural network, the higher dimensional version of the vector is a machine understandable meaningful data set. So it's a kind of like a representation of the picture. It's just a mapping from the pictures to a high dimensional vector. And in the high dimension, all the pictures are vectors. And we just try to calculate the distance between different vectors and group those vectors that are close to each other as a cluster. So it's kind of the internal mechanism behind it. So that's why we can see from this map, you can see these pictures looks pretty similar to each other, and these looks similar to each other, and these are very similar to each other. That's the reason why we get the output.
So it's like the pixel information and
The pixel information has been translated into a machine readable information based on the visual content. Yeah.
okay, great. And then slightly, like if you swing to the other side of it, you made some qualitative judgments, like, oh, this is not good on the cloud effect. How do you make that value judgment? Like, what do you think is good and not good?
This way, we have already identified the segments by ourselves. We know this part is Chenhang River, this is another river, and then we group them together. We just calculate the difference between them. It's very intuitively understandable. But this one, the machine do not know the location of this picture.
Right, but the other one where you were making your own value judgment, like, oh, this is overdeveloped. How do you know that?
We can find a lot of ways to but actually the mission here is a little bit different from saying how much it is over built in comparison to how much it is overbuilt to others. I mean, the comparison in between is more meaningful in this project. We are not trying to say this one is very high and that one is very low, but we're just trying to say it's very high in comparison to this area, and we just deliver the output for our customer and just let them to make the decision finalized. Yeah.
Yeah, this is obviously quite different from worrying about the ground level one, but there is actually a whole category of controversies that are going on at the moment in cities, and that has to do with heights of buildings and whether they should be clustered or not, view corridors to mountains that are beyond the buildings and other things. Have you tried any studies to try to put some quantitative dimensions to the question of how much in Vancouver, whether towers draw, in various kinds of locations actually form out views. In other locations that are dynamic, taking one shot, as we do down streets and other kinds of things. Have you done any of that kind of work that really works?
Yeah, I have done that work in street views, not this case, because we do not have the video shots for other rivers around the world, unfortunately. But that's another, that's a very good suggestion. We'd like to further extend our research in this area. But I have tried to identify the greenery views among all the cities in China. Many years ago, we did a collaboration with a professor in China and tried to identify all the street views. And the comparison among 300 cities is very meaningful. And it's kind of like convincing for us to understand how the situation it is. Especially this one is not that typical because we do not have large amount of comparable examples in other areas. Yeah, that is the shortage of this case, yeah.
without any.
Mm-hmm.
So I think that's
Mm-hmm. Yeah.
but I do like this example.
Yeah. Yeah. Yes.
Yeah, so can you elaborate also?
Yeah, that's a very good point. Actually, that's another reason why I choose this case. Yeah. So technically speaking, you're right. It's not very fully acceptable for everyone that we can detect all the pedestrian behaviors along the walk, along the sidewalks. But since we got the street view from Google Street View images, we can see it has already captured a lot of things along the road. Why not we can leverage the power of the data set to detect something beneficial for the city? So that's a very, very raw motivation for this type of research. But you're right, we should be very aware of those different legal issues in different cities across countries. Yeah. Be very careful. Yeah.
One quick last comment.
Interesting methodology to depict the parts of the landscape. And, we use this for a city. Normally, probably you would like to understand proportions of these elements to try to come up with some sort of quality. And we know that sometimes the quality is not the sum of each individual element. So I'm just wondering if in the machine learning world, you have a way of trying to single out the proper combinations beyond only the quantity. Is that my question? Do you understand my question?
I'm trying. Yeah.
Of course, you have the elements that you calculate. And might be that some images they have more of one kind, let's say windows or heights and things like that. And if you want to associate those quantities to certain types of qualities in that built environment, most often these qualities is not a function of a particular combination. It's not a particular. It's not the proportion of heights and needed to.
Yeah.
Did you understand what I mean?
Yeah.
Sometimes you want to, the quality is associated to some sort of a combination of elements that in one image, it's very different.
Yeah.
Still, if you end up with some sort of similar measure, but the images are very different. I guess it's a little bit what percentages there.
Yeah.
But assume that you can associate that quality. So my question is how you go about to try nowadays to do that in a more quantitative way, to try to extract that combined quality.
If I can paraphrase that, how do you measure the immeasurable?
It's a tough question. As we can see here, actually we can interpret them.
My point
is
a measure of quality. Can we dig out beyond the proportions,
I think the standardized answer to this question is we need to use our expertise to define the quality first, and then leverage the power of the techniques to measure them quantitatively. And once we found this measurement is not that good, we can go back to our definition back and try to define another way to use those techniques. Yeah, but my point here today is you can see we can interpret a lot of information from this kind of views. But in my case, we can only use the ratio, the pixel-wise means something like that, which is have been a huge deduction of the information we get from here. So I think the development of the techniques is still on the way. We can interpret more, extract more features from the pictures in the future. And also, I think it is very important to highlight the expertise and the knowledge, the domain knowledge from urban planning world, so that we can correctly use those techniques in our projects. Yeah.
Thank you.
Thank you.